Yes, yes, yes. It's time for some more calculations. And this time I'm going with a request that I got to talk about density and talk about the various calculations that we see when we are working with density. So we will need our calculator again. Put that off to the side for now. And let's take a look at the different possible types of calculations that we might need, as well as just talking about what is density. Let me see. Density, what is it we're talking about? So this is a property that all substances have. And it's not something that we can just look at the periodic table and immediately know what is the density. Whereas if we look at the atomic number, like here with nickel, if we look at nickel in a periodic table and we see 28, that tells us there's 28 protons in a nickel atom. Or if we look at the mass number, the mass here, this is a weighted average, we call it, an average of all the different isotopes of nickel. And throughout planet Earth, and really the universe, the average mass for nickel is 58.693 grams per mole. So those kinds of things we can get off of a periodic table. But density is something we cannot. We must make measurements to know what it is. Okay? So this comes from measurements. And often we can look up what the density is on a table, but it does help us if we're trying to figure out what is the volume or what is the mass. Density can help us because density, which I'll call lowercase d, is a ratio. And it is a ratio of the mass of the substance, whatever it might be, per unit of volume. How much space does it take up? So typically, in the laboratory or really everyday life, the mass that is very common to use for scientists is grams. And a volume that's very common when we're looking at liquids or solids is centimeters cubed. Okay, that is the same as milliliter. Those units are the same. Okay, so a centimeter, if we were to measure this out, and this were 1 centimeter times 1 centimeter times 1 centimeter, this takes up a volume, and that is 1 milliliter. So these units, as I said, these are common for liquids and solids. The reason why these units are not common for gases is because gases are so spread out. Liquids and solids are what we call the condensed phases. They're very close together, relatively speaking. Whereas gas molecules can spread way out from one another. And so, I'll put this here, that it's more common when we're talking about gases that we talk about in grams per liter. Common. And no, these are units, I should say, for gases. I'm going to be focusing on solids in this video, but it's analogous. All the calculations would be analogous for gases. Okay, so in terms of the kinds of calculations we might see, let's look at this one. Let's imagine. Let's do this example. Okay. If a piece of metal and we're going to imagine this is a pure metal. There's nothing else mixed in. It's not an alloy. It's just 100% one element. And if it has a mass of, let's say, we weigh it out, put it on a scale, and we find that it has a mass of 47.3 grams. And then we take that piece and we measure the volume of it. A really common way is you put something into water and you see how much the level of the water goes up in the test tube you have, or something where you can actually measure it, such as a graduated cylinder. The point is we have a volume. So, let's put what that volume is that you're able to measure. And in this case, in this problem, the volume is 2.45 centimeters cubed. So here are our two pieces of data. We know that density equals mass divided by volume. So we could possibly figure out what is the identity of this metal. If we have a table of all the metals and what their densities are, we could figure that out. So let's ask that question. What metal is it? Okay. So as long as we have a table or some way to find out what the densities are of various metals, we can figure this out. So first, let's calculate the density. We've got everything we need for that. So, our density, which is mass divided by volume, and our mass is 47.3 grams. And we'll divide that by 2.45 centimeters cubed. calculator. All right. 47.3 divided by 2.45. Alright. Looks like we have a 19.3 if we have three significant figures. So 19 we always want to report the units. So we look here and we see that we divided a unit of measurement that was in grams by a different unit of measurement that was in centimeters cubed. So we need to maintain all those units. So this unit is grams per centimeters cubed. And notice how I reported the final value as 19.3. Only three significant figures because we have 3 here and 3 here. And you can only have as many as the smallest number of significant figures when you're carrying out division. So even though the calculator told me that there was a lot of trailing numbers here, we don't use them. Okay. So we have a number here, and now we ask ourselves, what metal has a density that is close to this value here? There's our question. So this would entail going through a table, something that has density with it. Okay. So what you would eventually find is that it is this element here, AU. So this is the elemental symbol for gold. Okay, so we see right here the density is known to be 19.3 grams per cc. And you might say, what's the cc? We just decided it was 19.3 grams per cubic centimeter. Well, I just gave it away right there. cc means cubic centimeter. Oh, I got a little fluff on my pen. Cubic centimeter. So those units are the same, and we found our mystery metal. So let's ask another question. And why don't we relate it to this first question and just get an idea of the effect that density has on volume. So, with the second example, let's think about something that's definitely less dense than gold. And balsa wood is one of those things. Balsa wood, very, very not dense wood. So, let's ask ourselves, what volume this is related to the size, but specifically what volume of a piece of balsa wood would have the same mass. Okay, so we're talking about as this specific piece of gold. So, this piece of gold that we're looking up here is really not that large. So 2.45 centimeters cubed. Alright, so we're just looking at a piece, it's definitely, I could hold it in my hand pretty easily. So, let's look back at this relationship between density, mass, we'll call M, and volume. And so now we are interested in volume. So we want to rearrange this equation and solve for volume. So if we multiply both sides by volume, then that means we can cancel out volume, the numerator and denominator on this side. And then we can divide both sides by density. That allows us to cancel density on this side. Okay, so now we've got a way to calculate volume by taking the mass, dividing by the density. But now we're looking at balsa wood, right? So we need to know, what is it that we're talking about? What is it that the question is discussing? And because now we're curious about balsa wood, we need to get the value for the density of balsa wood. So if we look that up, because that is known, it is 0.161 grams per centimeters cubed. Alright, so now we can answer a question. What volume would the piece of balsa wood have that weighs the same as this gold up here? So we're going to say, alright, if it's 47.3 grams, we know the density is 0.161 grams per cubic centimeter. What volume is that? Alright, so let's take a look. Let's do this calculation. $294. Okay, so notice how this is 293.7888. Okay, once again, we only get 3 significant figures. And here, because it's 293.7, we round up to 294. 294 what? What are units? So if we take a look here, 294. We have grams, and we have grams. These cancel out. Now, this is a little bit tricky to see, but what we have is this whole thing is a denominator, but we have a unit that is a denominator of a denominator. And guess what? That moves it to the numerator. So our units are centimeters cubed. So look at this. Our piece of gold that was 47.3 grams was only 2.45 cubic centimeters. There's this little thing we can hold in our hand. Meanwhile, this piece of balsa wood, to have that same mass, has to be about 100 times bigger. Over 100 times larger. Okay, because balsa wood is so much less dense, so you need a lot more of it, a lot bigger volume, in order to get that same mass. Okay, so any of the calculations that you see with density, you can always come back to the original equation. I have it written here or written up here with the words. And if you know the mass and the volume, you can calculate density. Or if you know the mass and the density, you can calculate volume. Or density and volume, you can calculate mass. Any of those are possible with our density measurements and calculations. Alright, well, I hope this was helpful for you. Thank you for the question, for the curiosity, and I am always here for you. Give me your requests. I will keep answering them. I will keep creating videos for you. Please subscribe, and you'll get notifications every time I make a new video. And we'll see you again very, very soon.